Hi everyone, in this video I'm going to do a quick overview of circle theorems. So we'll talk about what the theorems actually mean, but we won't go into the proofs of the theorems. So let's start with a circle. The first circle theorem states that the angle at the centre of a circle is double the angle at the circumference standing on the same arc. So we can indicate an arc on our circle. It's just a portion around the outside of our circle. Let's also put a little red point, let's say that's the centre of our circle there. So this circle theorem states that if we have an angle to the centre of the circle, and an angle somewhere to the outside where these points meet at the edge of the arc, then if we call this angle theta, this second one will have to be 2 theta. And that holds whether we drag that angle around or not. Okay, so the second circle theorem. Let's start, we'll still have that arc. This time we'll turn it into a segment, so we're taking a portion of the circle as well, although this part isn't super necessary. But basically this circle theorem says that angles in the same segment of a circle are equal. So let's have a look at an angle. Here's one over here. Here's another over here. This circle theorem just states that both of these angles are equal. Okay, let's get another circle happening. Alright, so this is circle theorem 3. This circle theorem states that opposite angles in a cyclic quadrilateral are supplementary. So a cyclic quadrilateral is just a four-sided shape with straight edge sides that fits within the circle. So each of the vertices is on the circumference of the circle. This circle theorem states that this angle here plus this angle here have to add to 180 degrees, and this angle here and its opposite, this angle over here, also have to add to 180 degrees. That's circle theorem 3. Circle theorem 4 states that the angle in a semicircle is a right angle. So a semicircle is half a circle, and we're saying the angle in a semicircle is a right angle. So that's just saying if we make an angle by taking a line somewhere there and a line over here, we get a right angle. We could change that around if we wanted to. We could have it further up here, still a right angle. So it doesn't matter where we draw this angle to, as long as the vertices over here are on the edge of our semicircle, we should have a right angle there. Circle theorem 5 states that the tangent to a circle is perpendicular to the radius at that point. So let's start by drawing the radius. The radius goes from the centre of the circle to the outside of the circle. And let's draw a tangent to this circle. So a tangent to this circle hits the circle only once at this point here. So drawing by hand, it's a little bit dodgy, and you can sort of see I've got a little bit of overlap there. But the idea is that we should only actually touch the edge of the circle once, and this circle theorem just states that these two lines here are perpendicular. Okay, circle theorem 6. The angle made by a tangent to a circle with a chord drawn from the point of contact is equal to the angle in the alternate segment. So, let's make a tangent to our circle. Remember, it should touch only once. There we go. That's a bit dodgy again, but still, you get the idea. Okay, so we're making this angle. We're drawing a chord from the point of contact. So let's say that our point of contact is over here, and I just mucked it up a little bit. So it should... Let's see if I can get this right. Okay. So let's say our point of contact is this point over here. Let's draw a tangent. So we've got the tangent. Let's draw a chord. So there's our chord through the circle. We're saying the angle made by a tangent to the circle with a chord drawn from the point of contact. So that's this angle here. Oops, still got ink to shape on. This angle here is equal to this angle here. So that's what circle theorem 6 is. Circle theorem 7 states that if we have two chords in our circle, like that, let's do some labels. So if we call it A, B, E, C, and D, this circle theorem just states if we have A, E, that's our length here, and we'll multiply that, multiply that by EC, there, that has to equal to DE times EB. That's all of our circle theorems. I hope that helps understand them more.